Hey Team Bio, welcome to your screencast on energy flow and nutrient cycles, part 2, where we're going to add a little bit more detail to this understanding of how energy and nutrients are moving through the ecosystem. Okay, so you got the big idea about energy flow and nutrient cycling from the screencast previous, where you know that we need a constant supply of energy as an input into an ecosystem in order to keep the ecosystem running, because energy is constantly being lost in the form of heat that is radiated out into the universe. However, this is in contrast to nutrients, which are fixed and move from producers to consumers and decomposers. And then back into the abiotic environment, meaning into the ground or the water or into the air, where they're then picked up again by producers, and then they enter the biotic system once again. So nutrients are cycling around the ecosystem and energy is flowing through it. Okay, we're going to introduce an idea in today's screencast called the 10% Trophic Rule. And this is an energetic constraint of any ecosystem, which is that as you move up the food chain, up what's called the trophic level, 90% of the energy is lost as heat. And only 10% of the energy remains as chemical energy. And this constraint helps us understand a little bit more about the structure and size of any ecosystem. Okay, so let me give you a little bit more context about what that means. Here we have a graphic. It represents a food pyramid or a food chain. You've probably seen this idea before of we have a producer, which is eaten by a primary consumer, which is then in turn eaten by a secondary consumer, which is then eaten in turn by a tertiary consumer, and maybe this snake is eaten by a hawk. Ooh, I wonder if I could draw a hawk. No, not really. A hawk is going to come down and grab this snake. And if we saw that, that would be a quaternary consumer, a fourth level consumer. Okay, so this is a food chain. I'm sure you're familiar with it and learned about it in grade school. Over here is what we're really going to be focusing on, this idea of the 10% trophic rule. So every day, this is kind of crazy, 10 quintillion, that's 10 to the 19th kilocalories of light energy, which is the equivalent of the energy of 10 million atomic bombs, strikes the Earth's surface. And most of this energy is either absorbed by the atmosphere or scattered by the atmosphere or reflected by the atmosphere. But of the light that reaches the Earth's surface, only 1% is converted to chemical energy through the process of photosynthesis. So we're looking here at a very small area of the Earth's surface. So imagine on the small area of the Earth's surface, we have 1 million kilocalories of sunlight. And we know that only 1%, ooh, that's the wrong, I want to be here. Only 1% of that energy is converted from sunlight energy or electromagnetic energy up to chemical energy through the process of photosynthesis. That we're going to be studying later on in the year. Okay, so this box here represents the amount of energy that is stored as chemical energy in the bodies of all of our producers in this little sliver of the Earth's surface. So what that means is if we took all of the producers, all of the plants that were contained within this area, and we burned them all up, they would release 10,000 kilocalories of energy. Okay, so moving up to the next trophic level, you'll notice that our primary consumers, the box is much smaller. It's actually a tenth of the size of the box of the producers. And this is because of our 10% trophic rule. Plants are constantly emitting energy in the form of heat, and so are all of our primary consumers, our grasshoppers and such. So a grasshopper, in order to stay alive, it has to eat more plant matter than is just stored in its body, because it's got to move around. It's got to find a mate. It's got to have some babies. It has to find more food. It's constantly emitting energy in the form of heat. So if we took all the producers and we burned them all up, and then we gathered up all of our primary consumers and we burned them all up, we would find that only 10% of the energy that is the size of the producer box is stored within the primary consumer box. And then the same is true of the next level up. Our secondary consumers are also moving around, emitting heat, energy. And so if we were to measure the amount of energy that's stored in our secondary consumer trophic level, we would see that it is 1/10 of the amount of our primary consumers, and so on and so forth, until if we get up to the tippity top where we have our hawk system, there's only 1 kilocal worth of energy. And if you imagined something were eating the hawk, like, I don't know, a person, then that would only have a much even skinnier line. I don't even think I can make the line skinnier. Tiny line. This is 0.1 kilocalories of energy. So this is an energetic constraint, and helps us see why plants are much more abundant than our quaternary consumers like hawks. And also we see many more mice than we see hawks, and we see many more grasshoppers than we see mice. So ecosystems can only get so tall because of this 10% trophic rule, the fact that you're losing 90% of the energy every time you jump up a trophic level. So really, our primary producers, I want this to be bigger. Our primary producers, they set the energy budget for the ecosystem. Producers, their abundance determines how much or how high this pyramid can get before we just literally run out of energy. And yeah, that's the 10% trophic rule. Okay, see you in class tomorrow.